Hi everyone, welcome back. In this video, we will answer a very important question for Java developers. Will AI replace Java developers? The honest answer is no, not completely. AI is a powerful tool, but it is not a full replacement for Java developers. Now let's first understand what AI can help Java developers with. AI can generate boilerplate code. For example, it can quickly create a controller, service, DTO, repository, basic CRUD methods or configuration code. This saves a lot of time because Java projects often have repetitive code patterns. AI can also explain code. If you are working on an existing project and you see a complex method, AI can explain what the code is doing in simple words. AI can help fix errors. You can paste an error message or stack trace, and AI can suggest possible causes and fixes. AI can help write test cases. It can suggest unit test, mocks, edge cases, and test scenarios. AI can also help with refactoring. It can suggest cleaner method names, better structure, and simpler code. AI can help with documentation and debugging ideas as well. So yes, AI is very useful for Java developers. But here is the important part. AI helps with speed, but developers provide judgment. Now let's understand what Java developers still do. Java developers understand requirements. AI can generate code only when the requirement is clear. But in real projects, requirements are often incomplete, changing, or unclear. A developer talks to product owners, business teams, QA teams, and other developers to understand what exactly needs to be built. Java developers understand business logic. For example, payment rules, discount rules, order processing rules, approval flows, reporting rules, or security rules. AI can suggest code, but a developer must verify whether the logic matches the real business requirement. Java developers design architecture. They decide how different parts of the system should communicate. They decide whether to build a monolithic app or microservices. They decide how to handle database transactions, API contracts, caching, messaging, scalability, and failure handling. AI can give suggestions, but the final architecture decision needs experience and context. Java developers also handle security. They decide how authentication works, how authorization works, how sensitive data is protected, and how APIs are secured. This cannot be blindly trusted to AI-generated code. A developer must review it carefully. Java developers also care about performance. A code snippet may work for 10 users. But will it work for 10,000 users? Will it create too many database calls? Will it cause memory issues? Will it slow down the application under load? These are developer responsibilities. Java developers also work with databases and APIs. AI can draft SQL queries, repository methods, and API usage examples. But developers must design the schema, choose relationships, handle transactions, manage indexes, protect data, and validate final integration. Java developers also handle deployment and production. AI can suggest Docker steps, Kubernetes configuration ideas, monitoring setup, or deployment commands. But developers decide release strategy, reliability, scaling, rollback plans, and incident handling. When production breaks, AI does not take responsibility. The developer and the team do. Now let's look at real-world examples where AI helps and where developers decide. Example 1. Building a Spring Boot REST API. AI can generate controller, service, DTO, repository, and basic CRUD code. But the developer still defines requirements, business rules, validation rules, error handling, and API design. Example 2. Fixing a Java error. AI can explain the stack trace and suggest possible fixes. But the developer must reproduce the bug, test edge cases, and verify the actual root cause. Example 3. Writing unit test. AI can generate test cases and mocks, but the developer decides the right test coverage, validates behavior, and maintains test quality. Example 4. Refactoring code. AI can improve readability and suggest cleaner methods, but the developer must review performance, maintainability, and production safety. Example 5. Database and API integration. AI can draft SQL, repository queries, and API usage examples, but the developer designs the schema, checks security, handles transactions, and validates integration end-to-end. Example 6. Deployment and production. AI can suggest Docker, Kubernetes, and monitoring ideas, but the developer makes release decisions, manages reliability, handles scaling, and responds to incidents. So the message is very clear. AI is an assistant for speed. Developers provide judgment, architecture, and responsibility. Now let's talk about the future. A Java developer who ignores AI may become slower. A Java developer who learns AI tools can research faster, code faster, test faster, and learn faster. But using AI does not mean blindly copying and pasting code. That is dangerous. AI-generated code can have bugs. It can miss edge cases. It can create security issues. It can use wrong assumptions. It can generate code that works for a demo but fails in a real project. So the best approach is simple. Learn AI tools. Use AI to save time. Verify the output carefully. Keep improving your Java fundamentals. Keep learning system design, databases, APIs, security, testing, cloud, and production practices, because Java skills still matter. Problem solving still matters. Architecture and system design still matter. And learning AI tools is no longer optional. Quick rule: AI will not replace Java developers, but Java developers using AI will replace developers who ignore AI. That is the real future for Java developers in the AI era.